My name is Keith Schultz, and I'm going to be covering a little bit about NXCam, their new probing interface. Let me get my screen shared here. All right, so NXCam has a new on-machine probing module, and we're going to be talking about that this morning. This is going to be an overview of use, and we're also going to be look at getting some additional features to download in an NX from PostHub, such as the simulation and the post-support layers. So this is what we're going to talk about. We're going to look at the Siemens cinemeric side of things. So on the Fanuc side, there's more features, and we decided to give that its own showcase later. So this is going to be a brief informational presentation to let you see the new interface, and we encourage you to download it and play with it yourself. All right, so what is OMP4? So most of us have probably heard the term probing, and most machine tool manufacturers have provisions for probing. And automated tool setting is the standard for setting our tool offsets. So while NX is not new to probing operations, this new module will help you streamline your programming workflow. So no longer do we need to generate each move separately. So OMP is exactly what it sounds like. It's measuring a feature while it's on the machine tool. So why use it? Why use OMP? So if you want to digitally expand your machine shop, you can become more effective, efficient, and profitable. A digital shop provides powerful advantages, including reduce our turnaround time. We can deliver high-quality parts on time by predicting and eliminating errors by using a digital twin of your part. And we can expand and grow our business by implementing new automation technologies. So probing critical dimensions in our workpiece can reduce our scrap rate by allowing us to measure and adjust processes while the workpiece is still in the machine. So what does a digitalized workflow for our part look like? So it might look like this. We can probe our tool to check for breakage and update our wear. We can then probe our stock to check for errors in setup, operated or robot tended. And we can make fine adjustments to our works offsets that we can use logic if it's off enough to throw our operator in error and get that some special attention, right? So after machining, we can promote critical dimensions and adjust our process and have an automated rework process, or we can write logic to an alert operator again. But in the long run, we can also capture this data and follow the trends for tool life. We can use that to keep our process under predictable control. So instead of switching to a backup tool once we detect breakage, we can determine that, after so many parts, we probably should switch to our backup tool. So let's talk about robot tendon CNC machines, right? So a crucial part of a robot tendon machine cell is going to be probing. So why? So if we want to be able to run a lights out process, we need to ensure our part is correctly loaded. So being able to check that the robot and machine work together to load that part correctly can save us costly errors and some pretty grisly non-wanted results. So what are the probing cycles first? So the OMP solution, it offers the possibility of certain measuring operations before, during, and after a machining operation. So this provides functionality to pre-program the control measurement cycles in our digital twin. Going out to your machine and hitting buttons isn't going to save you any time, right? And we can verify that these same toolpaths on our digital twin in real time and react to those measurement results. So a cycle is generated by the post processor that executes measurement macro available on the machine tool. So these cycles are machine tool specific to the manufacturer. So what can you measure? So if the probe can get to it, we can measure it. So there's a lot of options here. You can see some of these small thumbnail images. There's options for measuring pockets, bosses, ribs, and planar surfaces. We can also measure a linear vector based on 2 pockets, which I thought was pretty cool. And we can also modify these cycles in a user-friendly operation dialog. So how to use on-machine probing cycles. So a whole range of cycles are provided for programming, but unlike what you might expect, you don't have to select the cycle first and then select geometry. And then send, kind of like the toolpaths are that you create now in NX. Instead, what you do is you select the geometry And then you get a suggestion of which cycle you're supposed to use to measure that geometry. So let's take a look at this module. So I have my part set up here, and I've determined, here, look at our workpiece. So I'm using the master model process as well. We have our part defined. We have a blank model we brought in defined, and we also have some check geometry. All necessary steps whenever you're setting up an operation. So first thing we want to do if we want to start probing is we need to create a tool. And you see this automatically comes up because I've used it recently. But you can see we have a probe option here. We can also, we can make a tool ourselves, or we can select a tool from our library. And that's those are located in the solid tools in the probes. And you can select between your different library units. And when I say OK to this dialog, you'll see that 2 probes show up, and we can select one of these. Now, if you have to create your probe, you're going to have to give it its mounting location, the length from the mounting location, and you're going to have to identify the tip. All right, so now let's create an operation. I'm going to switch over to my operation view, my program order view, and we're going to start creating an operation. So I already have probing set up, but you can see that's going to show up over here in your type. And I'm going to put that into our probe work offset. This will be one of our first operations we do. My tool is a probe, and our geometry is going to be workpiece. And we're going to use a method here, and this might seem a little different to you. I've created a method, and I'm going to show you real quick how we use these methods in probing. So if I come over here to create method, what you see in here is we can have our tolerances, and we can also put our feeds in here for our probing. So depending on what type of probing you're doing, if you're just locating stock and setting your work offset, you might not need a huge, a very small tolerance. You might need a bigger tolerance. But if you're programming to look at a feature and make sure it's within tolerance, you might want to change these numbers to whatever your tolerance is. So that's how that works. All right, so we have all of our 4 parents populated, and we're going to name this operation our find Z. Very common thing we do first. Select OK, and we see the new dialog box. So this is how the workflow works in this, is we're going to select our geometry. A cycle is going to show up, and then we're going to hit our probing parameters, and that's where we're going to do our changes to our cycle. So for now, I'm going to select this top face of our stock, and OK. And here we go. We get to see 3 cycles that show up. And if you hover over each one, you'll get a description and a cycle number, which is also over here, of course. There's a single edge. There's aligning a single edge. And there's aligning a surface to a plane. So right now we're just trying to find and set Z. We're going to stay there, and we're going into our probing parameters. So looking here, we have a whole bunch of locked boxes. Let's unlock some of these and see what we have in here. Set them all to user defined. And the first thing it's property to do is a measurement point. Right now it's going to be the center of the part, but I'm going to just move it off the center of the part just so we can see that the tool path has already been created. And we're going to select our offset target, and we're going to put that as our work offset. You see a couple more windows open up, so let's go ahead and unlock those. And we have a few options here, either our active work offset, or this is for cinematic control. And you can see that we have all the available options there for the controller. I'm going to select G54. All right, we're done there. I'm going to select OK and generate the operation. And there you have it. So, and what's the next thing we might want to do is we might want to find the center of this stock in X and Y. So we're going to create another operation. We're going to call it find XY. And everything else is going to be the same. We're going to the program is going to be in our probe work offset subprogram. We're going to be using our probe again, and the workpiece, and we're going to use our probe work offset method. Once again, the same workflow applies. We're going to specify our probing geometry. It's going to be outside of the cylinder, and it'd be the same thing if your stock was a rectangle. You'd select all 4 sides. Select OK, and I'm going to get some options. So we have a spigot, cycle 977, or we have a spigot with just a auto circle segment. We're going to select that first one and look at the parameters. And you'll see the first thing that comes up is this measuring point. And what that is basically how far down on this stock do we want to measure. So I'm going to bring that up a little bit higher. And so let's look at some of these options in here. Once again, we can select our work offset, define our work offset that we're going to use. And let's unlock this right here. And we're going to have this user be defined. So we want to use our center point offset, right? Once we're done, I'm going to select OK, and we can generate. Now that's all generated. So earlier we talked about using a robot tended cell and how you might need to make sure this part is mounted correctly. So if that part wasn't mounted correctly, you wouldn't want to go and adjust an offset. You might want to put some logic in there that basically stops everything, gets the yellow light blinking and gets an operator over there. So let's see how that works. We're going to use the same kind of thing, and we're going to use we're going to check plane. Remember, you can't use spaces in X. And we'll use all the same settings in our parents. All right, once again, our workflow is to specify our geometry. In this case, it's the face. And we're going to come down to this 3D align plane. And once again, you can hover over it and it's going to tell you what it does. All right, once I have that selected, let me go into probing parameters and see what different things we have here. The first prompt it's going to give you these, it works off of 3 measuring points. You can't get a plane off of just 2 measuring points. So you're going to have to select each one individually. Get that right. There we go. Make sure you have your green check mark as well. There we go. Select OK. And let's look at our probing parameters. So in this case, we have options of work offset or measuring only. Maybe we wouldn't want the table to tilt and we might want to just measure only. Oh, looks like I have to reselect my points. There we go. And we can generate that. I'll select OK. And while we're here, I want to just show you one more thing, is that we can actually run that simulation in the graphics window. There you go. So let's talk about some of these mill control operations you see up here. Some of these operations will require you to use a mill control operation, but luckily NX has given us some samples that we can just plug into our mill control operations. So if I go to create a mill control operation, and I need to enter some logic, let me click on notes. I can go ahead and grab this, and this came from the probing cycles templates, and you can see we already have some logic up here, right? So let's just put any one of them in here. Here we go. And you can see that that populates with your Cinemerica machine code. And you could put multiple things in here. You can actually, this is where you could put your logic to actually have the machine stop there and get the operator to come and look at what your robot did. All right. So let's get back into our PowerPoint. So we've done all this. So we saw how this is how the NX on-machine probing module currently works. And Siemens is really leaning heavily into Industry 4.0, and they have been for a while. So they're expanding this offering. So this module looks like it will take, this new adaptive machining module looks like it will take some more of the work out of our workflow and take care of some of the logic operations. I'm not sure, but this text here that you're looking at came directly off the Siemens site. So we're really excited to see what they're going to come up with there. So this is going to be a huge benefit for your digital manufacturing process. So if you currently don't update your NX version, you might want to consider upgrading when this module comes out. And of course, we will post another video about it when it is established. So setting it up. So there's a few things we need to do to get this run correctly in NX. And so updating cycles. So the out of the box on-machine probing control cycles released in 2306 and later are under maintenance. So they're continuously updating. I think new updates are dropping all the time. So therefore, possibly has been created to download this content via Siemens NXCam Post Hub. So for your post processor, you need to download the on-machine probing post layer. So in order to obtain a machine cycle via the post processor, it is necessary to extend the custom post processor. For this purpose, you go on Post Hub and you can add this layer in your post configurator. The example provided is on the basis of a non-tailored post processor, and it may be necessary to make adjustments. So always check for your correct outputs. So if you want to use machine simulation, there's also the CSE, simplified probing routines. So in order to be able to simulate any machine cycle via the machine simulation, it's necessary to extend your existing CSE simulation. There's also an example of that on Post Hub. So included the required subroutines. So in order to verify the desired simulation in the machine cycle, the example is provided on the basis of a non-tailored simulation. So once again, you want to check those before you run on your machine. So how do we get all this free stuff? Obviously, we got to go to Post Hub. If you haven't from NX gotten to Post Hub before, you can just type in into your search bar at the top left of your, top right of your NX screen. So you're going to need your Siemens sign-on from your org, or if this is your own personal NX, you enter your data in there. All right, so once you download and unzip these files, you can open up the folder structure, and you're going to find this great tool in there, this folder called documentation. So you're going to have a handy little instruction document in PDF to help you guide you through the installation process. And there's also another way to get the expanded cycle package installed. So there's a script that comes along with that unzipped file. And it's called on-machine probing installation.bat file. So we can also manually move these expanded features. But if you're going to use this installation.bat script, a special note is if you have a space in your file path like I do, so like C / program space files, it's not going to work for you. I even tried, putting some parentheses in it. It didn't work very well. But what it has you do is take a log file and drop it into the folder where that installation script is, and it looks for where your probing is located, and it's going to drop those files in for you. If you can use it, it's going to save you a little time. All right. So I hope you enjoyed this taste of the new probing interface, and we hope you get a chance to download it and experience yourself. And if you're part of an organization that's currently like on NX 11 or really far behind on their version of NX, hopefully you convince them to upgrade, especially with the new adaptive machining module coming out from Siemens. So expect to see more from us on probing in the future. And for now, we're going to take, after we get some questions, and I want to know if anybody has any questions.